Hi, I'm Vani and I'm part of the team The Confusion Matrix. I worked on cleaning the user-defined tags to group them into semantically similar tags that we use to assign genres to the books in the dataset. I also worked on assigning a genre spread variable to each of the transactions in the dataset.
Hi, I'm Varsha and I'm a part of the team, The Confusion Matrix. I worked on the pre-processing of the data, in specific, manipulating the user ratings of the books to generate transactions. I also helped with the evaluation of the model using certain parameters, comparing the models and selecting the best one. Hi, I'm Shruti from Team Confusion Matrix. I worked on building the model for various forms of the transactions and helped to evaluate the models and come up with the final one. I also worked on the user interface.
Large amount of consumer data available today, market basket analysis has proved to be an effective way of understanding purchasing behavior. In the context of bookstores, market basket analysis can be used to group books together into baskets based on customer likes and dislikes. These baskets could be considered as shelves of books or gift boxes for customers, depending on the required application. In the end, the motivation is to use the available data to boost sales and better customer experience.
The dataset used was GoodBooks 10K and it was found to be mostly clean. As the first step of pre-processing, we discarded the bottom 10% of the books as per the average ratings. Next, the ratings were grouped by user ID and transactions were created. In one set, the lower rated books for each user were split into a separate transaction, and in the other, they were discarded. This was done to experiment with the transactions to see which set would yield better results. Finally, the tags assigned to books by users were cleaned and grouped to create genres for the books. Genre spread, that is, the ratio of unique genres in a transaction to the number of books in that transaction, were computed for each transaction in the two sets.
The training and testing data sets were created from the transactions. An 80-20 split was used for this. The user is requested to supply the input parameters. At least one book should be specified. The other books will be selected in such a way that they are similar to this input book. The user can also select the desired genre spread, either high or low. If there is no preference, the option random can be selected. The number of books to be added to the basket is also taken as input. Threshold values for support and confidence were chosen by running the algorithm for multiple different values. Finally, the values which resulted in an optimal number of rules being generated, even for rare books, were selected. It is important to note that here we are not too selective or too lenient with respect to the strength of the generated rules. The value selected through trial and error was 0.01 for min support and 0.3 for min confidence. The transactions were previously split into those with high genre spread and low genre spread based on the mean value of the genre spread computed over all transactions. The transactions corresponding to the required value of genre spread as per the input were selected and the a priori algorithm was run. From the association rules generated, the books which best satisfied the input criteria were displayed as the books assigned to the basket. This was done for both sets of transactions as generated while pre-processing, and the models generated with the two were compared. Here is an interactive graph that represents the rules with items as labeled vertices and rules represented as vertices connected to items using arrows. The LHS items are connected with arrows pointing to the vertex representing the rule, and the RHS has an arrow pointing to the item. Here is an example for the rule generated for input given as book IDs 13,4 and the RHS being book ID 4. The parameters associated with this rule are found in the box.
We use average co-occurrence to evaluate the models. Once the basket has been generated, we compute the co-occurrences for every transaction in the testing dataset. Co-occurrence of a transaction given a basket is the number of books in the intersection between the basket and the transaction. Only the lengths of intersection greater than 0 are considered. Finally, we use the average of the co-occurrences over all the transactions to compare models. The ideal co-occurrence value would be equal to the basket size. The model was run for both the transaction sets. 10% of the books in the testing data set, that is, around 1000 books, were selected randomly to run the models. The variation in the average co-occurrences were compared, and it was discovered that the second set, which included only the higher rated books per user, had better co-occurrence values.
A subset of the transaction set was created based on which transactions were in the input range of genre spread. After running the a priori algorithm, the association rules with the highest values of support, confidence, and lift were chosen, and the basket was generated while taking into consideration the required genre spread. This extra check was done because while generating baskets for high genre spread, it was discovered that the strongest association rules still suggested books of the same genre as the input book. In retrospect, this observation was not very unexpected because the data consisted of many books belonging to the same series or general topic, and most books of the same series were rated similarly. Converting ratings of books by users into transaction-like entities enables the use of market basket analysis for the problem at hand. It was also established that the low genre spread choice can be used to shelf books at bookstores, enabling easier access and leading to a better organization of the shelves in the store. The high genre spread choice can be used to generate baskets with variety in them, and this can be used to make gift boxes for customers.